At the end of this video, you should be able to distinguish between the physical properties and chemical properties of matter, and classify changes of matter as physical or chemical. Chapter 1, Section 2, Matter and its Properties. Look around you. You can see a variety of objects: books, desks, chairs, and perhaps trees or buildings outside. All of those things are made up of matter, but what exactly is matter? What characteristics or properties make matter what it is? In this section, you will learn the answers to these questions. Explaining what matter is involves finding properties that all matter has in common. That may seem difficult, given that matter takes so many different forms, but for a moment, just consider one example of matter: a rock. The first thing you might notice is that the rock takes up space. In other words, it has volume. Volume is the amount of three-dimensional space an object occupies. All matter has volume. All matter also has a property called mass. Mass is a measure of the amount of matter. Mass is the measurement you make using a balance. Matter can thus be defined as anything that has mass and takes up space. These two properties are the general properties of all matter.
Everything is made of matter. Matter is defined as something that has volume and mass.
You know that matter comes in many forms. The fundamental building blocks of matter are atoms and molecules. These particles make up elements and compounds. An atom is the smallest unit of an element that maintains the properties of that element. An element is a pure substance made of only one kind of atom. Carbon, hydrogen, and oxygen are elements. They each contain only one kind of atom. A compound is a substance that is made from the atoms of two or more elements that are chemically bonded. Many compounds consist of molecules. Water is an example of a compound. It is made of two elements, hydrogen and oxygen. The atoms of hydrogen and oxygen are chemically bonded to form a water molecule.
A compound is a material made up of a group of atoms bonded together in a regular fashion in predictable numbers. The active ingredient in aspirin, for instance, contains many units or molecules that can be represented by the structures shown here. Each has 9 carbon atoms, 8 hydrogen atoms, and 4 oxygen atoms. If the molecule doesn't contain these elements in this arrangement, it isn't aspirin. Bonds hold the atoms in chemical compounds together. Compounds have properties that are very different from their original elements. In contrast to aspirin, which contains carbon, hydrogen, and oxygen, the elements hydrogen and oxygen are gases at room temperature. One form of carbon is the solid found in pencil lead.
You will learn more about the particles that make up compounds when you study chemical bonding in Chapter 6. For now, you can think of a molecule as the smallest unit of an element or compound that retains all of the properties of that element or compound. Every substance, whether it is an element or compound, has characteristic properties. Chemists use properties to distinguish between substances and to separate them. Most chemical investigations are related to or depend on the properties of substances. A property may be a characteristic that defines an entire group of substances. That property can be used to classify an unknown substance as a member of that group. For example, one large group of elements is the metals. The distinguishing property of metals is that they conduct electricity well. Therefore, if an unknown element is tested and found to conduct electricity well, it is a metal. Properties can help reveal the identity of an unknown substance. However, conclusive identification usually cannot be made on only one property. Comparisons of several properties can be used together to establish the identity of that unknown. Properties are either intensive or extensive. Extensive properties depend on the amount of matter that is present. Such properties include volume, mass, and the amount of energy in a substance. In contrast, intensive properties do not depend on the amount of matter present. Such properties include the melting point, boiling point, density, and the ability to conduct heat and electricity. These properties are the same for a given substance regardless of how much of that substance is present. Properties can also be grouped into two general types: physical properties and chemical properties.
Extensive properties depend on the amount of matter that is present. For example, the volume of water in the small beaker is 25 milliliters, and the mass of that water is 25 grams. The volume of water in the large beaker is 100 milliliters, and the mass of that water is 100 grams. Intensive properties do not depend on the amount of matter present. For example, at standard pressure, the boiling point of water is 100 degrees Celsius, no matter how much water is present. Similarly, at 4 degrees Celsius, the density of water is 1 gram per milliliter, regardless of how much water is present.
A physical property is a characteristic that can be observed or measured without changing the identity of the substance. Chemical properties describe the substance itself rather than describing how it can change into other substances. Examples of physical properties are melting point and boiling point. Those points are, respectively, the temperature at which a substance melts from a solid to a liquid and the temperature at which it boils from a liquid to a gas. For example, water melts from ice to liquid at 0 degrees Celsius, which is 273 Kelvin or 32 degrees Fahrenheit. Liquid water boils to vapor at 100 degrees Celsius, which is 373 Kelvin or 212 degrees Fahrenheit. A change in a substance that does not involve a change in the identity of the substance is called a physical change. Examples of physical changes include grinding, cutting, melting, and boiling a material. These types of changes do not change the identity of the substance present. Physical properties can be observed without changing the identity of the substance, but properties of the second type, chemical properties, cannot. A chemical property relates to a substance's ability to undergo changes that transform it into a different substance. Chemical properties are easiest to see when substances react to form new substances. For example, the ability of charcoal, which is just carbon, to burn in air is a chemical property. When charcoal burns, it combines with oxygen in air to become a new substance, carbon dioxide gas. After the chemical change, the original substances, carbon and oxygen, are no longer present. A different substance with different properties has been formed. Other examples of chemical properties include the ability of iron to rust by combining with oxygen in air, and the ability of silver to tarnish by combining with sulfur. A change in which one or more substances are converted into different substances is called a chemical change or chemical reaction. The substances that react in a chemical change are called the reactants. The substances that are formed by the chemical change are called the products. In the case of burning charcoal, carbon and oxygen are the reactants in a combustion or burning reaction. Carbon dioxide is the product. The chemical change can be described as follows. Carbon plus oxygen yields or forms carbon dioxide. Arrows and plus signs can be substituted for the words yields or plus, respectively, as is shown at the bottom of the screen here. The decomposition of the mercury compound shown on the screen here can now be expressed using the same arrows and plus signs representing the words yields and plus. Chemical changes and reactions, such as a combustion and decomposition reaction, form products whose properties differ greatly from those of the reactants. However, chemical changes do not affect the total amount of matter present, either before or after a reaction. The amount of matter, and therefore the total mass, remains the same.
When liquid bromine is added to aluminum foil, the two substances react. Heat and light are indications of a chemical reaction. Aluminum bromide is produced and deposited onto a cooler surface.
Breaking a piece of chalk in 2 or more pieces is an example of a physical change. Regardless of how many times the chalk is broken, it is still chalk. The physical properties of size and shape are altered, but the chemical properties of the chalk remain the same. An example of a chemical change is baking a cake. When baking a cake, eggs, flour, sugar, oil, and other ingredients are combined. Each ingredient has its own set of properties. If the ingredients are mixed together and baked, something completely different is created. The heat from the oven and the interaction of the cake ingredients cause a chemical change.
At this point, you should be able to distinguish between the physical properties and chemical properties of matter and classify changes of matter as physical or chemical.